All right, you guys, today's video is going to be nice and short. I just want to kind of make a point before you start working on your practice assignment for today. So pause when you get a second to try this warm-up, and then when you're ready to see the answers, go ahead and keep going. All right, so use the quadratic formula to solve for the x-intercepts. What do you notice and what's weird about your answer? Well, obviously something's going to go wrong, right? Like something's going to be unusual where we're going to get stuck, so I'm kind of already prepared for that. So quadratic formula, negative b plus or minus b squared minus 4ac all over 2a. So we get negative 4 plus or minus, and there's a 2 on the bottom. 4 squared is 16, and then 4 times 1 times 5 is 20. So I get negative 4 plus or minus the square root of negative 4 over 2. Okay, here's a problem. What in the world is the square root of negative 4? If it were square root of 4, I'd say plus or minus 2, no problem. But there's no two numbers that are the exact same number that when you multiply them, you get a negative out, right? A negative times a negative is a positive, and a positive times a positive is a positive. So here's what this means. At this point, and especially in Algebra 1, all you need to know is this is what's called imaginary solutions. If you can see that negative underneath and go, oh, the solutions are imaginary, call it good. In fact, normally what you would do is, since the square root of positive 4 is 2, you would write it like this. So what happens is, it's almost like you split up the negative 4 into 4 times negative 1. The square root of 4 is 2, and the square root of negative 1 is called an imaginary number, and we call it I. If that part makes sense, this whole 2i part, awesome. If it doesn't, that's okay. You're not going to actually need that until Algebra 2 trig. The main thing for you guys is when you see a negative under that square root, you should be thinking those solutions are imaginary and they don't exist. So for letter B, when it says change the equation into vertex form by completing the square, I'm going to do the diagram way. So here's my x squared box. There's 4 x rectangles total, so there's 2 on each side. So this would be x plus 2 quantity squared. We have 5 pieces, but this diagram only needs 4, so it's almost like we have 1 extra. So this is what it would look like in vertex form. So if I go to graph that, I'm going left 2 and up 1 to make my vertex, and then using the 1, 3, 1, 2, 3, 4, 5, the 1, 3, 5, 7 rule on either side, and my quadratic looks like this. So the question says, why might your answer to letter A make sense now? Here's why it might make sense. When you're using the quadratic formula to solve for the x-intercepts, we got imaginary x-intercepts, which means they don't exist. Look at your graph down here. Do you see any x-intercepts? No. So that's kind of your hint. If you do get x-intercepts, you know that the quadratic somehow crosses the x-axis, okay? But if you don't, if you get imaginary solutions, that means that the quadratic, when you graph it, never crosses the x-axis, and that's why those solutions are what's called imaginary. So kind of cool. That's a little twist that you don't need to know as well, but it will come back for you guys when you go to take Algebra 2, okay? All right, so today you're going to be working on a worksheet that's going to help you make connections, and really it's going to make or break your understanding of this unit. Making connections as to no matter how I solve a quadratic, I should get the same answers every single time, okay? So let's read through this together and then you can start the assignment. Carlos and Clarita, Tia and Tayani, and their best friend Zach are all discussing their favorite methods for solving quadratic equations of the form ax squared plus bx plus c equals 0. Each student thinks about the related quadratic function as part of his or her strategy. So Carlos says, I like to make a table and find the solutions by inspecting the table, meaning if they're x-intercepts, he's going to look for number comma 0 in a table by just plugging in numbers. Carla likes to write the equation in factored form. Tia likes to write it in vertex form and solve it. Tayani likes to use the quadratic formula. And then Zach likes to graph it. So you'll notice when you go to look at the assignment, the whole idea is you're going to take one equation that I give you, and you are going to solve it or find the x-intercepts using all 5 methods, okay? If you're using the same exact quadratic and you're solving it in 5 different methods, keep in mind your answers should be the same exact answers all 5 times, okay? So for example, if you get an x-intercepts of, I don't know, 3 plus or minus 2 root 7 or something like that, you should expect when you go to graph it to have kind of weird x-intercepts that are not really nice numbers, okay? Versus if your answers are x equals 3 and x equals 2, you should get really nice x-intercepts, that sort of a thing, okay? So keep that in mind. Do not put too much pressure on yourself. It does start out, in my opinion, it starts easy and it progressively gets a little bit tougher. So use the answer key to your benefit. Let that answer key, I've showed a lot of my work, so let it kind of drive you and help you make these connections. The more connections you make with quadratics, you guys, right now, the better off you'll be in Algebra 2. Trust me, okay? Don't forget, if you have questions, I'm available for office hours today, so stop by and let me know how I can help.